Hello, seventh graders. Our lesson today will be lesson 7.1. We will be working in the math book from pages 203 to 210. So if you need to pause the video to get your math book, go ahead and do that, and then I will meet you back here in a moment. Okay, welcome back. We are working on writing and solving one-step inequalities. The standard that we will be using is EE4. I can solve inequalities and graph their solutions. So, what is an inequality? An inequality is a relationship that shows that two expressions are not equal. So here are some examples. I'll just move this down for the moment. Some examples include 6 is less than 10, -4 is greater than -20, and 3x plus 4 is greater than 25. So that's what we'll be looking at. The good news is that inequalities are solved almost identically to the expressions we have been solving with the equal sign. So there's not going to be much difference. There's a couple of little nuances, but other than that, it's going to be very similar to the last unit. So if you like the last unit, I think you'll find this is just as easy. Okay, let's get started. Okay, I've decided today to try to work like we used to do in class with the document camera versus trying to do all of the different math things on the screen. So we'll see how this works. This is all trial and error. We're learning as we go. I'm sure you're learning as well as I am how this online learning is going to work. So first of all, if you remember right, if I was to say 10 is greater than 3, I know that my open mouth Pac-Man always eats the bigger number. So keep that in mind when we're doing this unit. 10 is greater than 3. But I would read this as 3 is less than 10 because you read from left to right. So in our case, 3 is less than 10. If it was written like this, now Pac-Man is still eating the bigger number, he's just going the other direction. 10 is greater than 3. So this one goes with that statement, and that one goes with that statement. Okay, I'm giving an example here. We're going to talk about adding and subtracting with inequalities. First, I put one from our last unit. X plus 5 equals -12. So how would you solve this? If you remember from the last unit, you would use inverse operations to subtract 5 from both sides. If I do that, I end up with x plus 0 equals 12 minus 5. Now 12 minus 5 is the same as 12, it's -12. -12 minus 5 is the same as -12 plus -5. So -12 plus -5 is -17. Drop the 0, because 0 plus any number is just the number, in our case x. X is equal to -17. So I think we're all familiar with how to do that. What would change if I were to write x plus 5 is less than -12? Move this up a little bit. X plus 5 is less than -12. I would do exactly the same thing as I do if there's an equals here. So I'm going to subtract 5 from both sides using inverse operations. And I'm going to get x plus 0 is less than 12, negative 12 minus 5, or negative 12 plus negative 5 is negative 17. I'm going to drop my 0. X is less than negative 17. Good. So now we have to learn how to graph that on a number line. So I'm going to draw a number line going both directions here. And I'm going to put some numbers here. I'm not going to put them all on there. I'm going to say negative 17, negative 18, negative 19, negative 20, and it would continue forward. This would be negative 16, negative 15, dot, 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 till I got to 0. Then I'd have 1, and I'd have 2, and I'd go the other direction, correct? So when we graph this, we are saying, and this is where I said the Pac-Man is going to come in handy here. This is saying that x is less than negative 17, because Pac-Man is going to eat the bigger number. So to graph this, we are going to put a circle, an open circle on negative 17, and we're going to draw an arrow that goes that way, because the solution to this inequality is numbers that are less than negative 17. So it's going to go that way. And you might be asking, why do I have an open circle here? The open circle means that negative 17 is not included in the solution. The solution does not include negative 17. It only includes numbers less than negative 17. And remember, with negatives, the farther you are from 0, the smaller the number. So if you think about it, you'd rather play outside at negative 17 degrees than at negative 20 degrees. Negative 20 is farther from 0 than negative 17. Now we're going to need to check that we got the right answer. Everything has a way of checking. We learned in the last unit that to check, we would just plug in the solution for x. So that is what we're going to do within an inequality, just in a little bit of a sort of a different format. You have x plus 5 is less than negative 12. That was the original equation. Now we know that x is not just one value now. X is actually going to be any number less than negative 17. So I'm just going to pick a number less than negative 17 and try it. If it works in the statement and it comes out true, then I've done the inequality correctly and solved it correctly. So I'm going to put negative 18 in here because negative 18 is less than negative 17. I'm going to add 5. The answer should result in being less than negative 12. So let's see if that works out. Negative 18 plus 5. So that's like subtracting 18 minus 5. So 13, negative, right, is less than negative 12. Is that negative 13 less than negative 12 a true statement? Is negative 13 less than negative 12? The answer is yes, it is a true statement. How do I know that? Because negative 13 is farther from 0 than negative 12. I'd rather play outside at negative 12 degrees than negative 13 because negative 13 is colder or lower in temperature. Okay, what would happen if instead of x plus 5 is less than negative 12, I've had this little line underneath? What would that do to my solution? Well, let's see. We would still subtract 5 from both sides. We would still get x plus 0 is less than negative 17. X is less than negative 17. But what does that little line under there mean? Correct. It means or equal to. So now in this situation, x is less than or equal to negative 17. Before we had x is less than negative 17, and we didn't have that little line under there. So how would you graph this? Well, you draw your number line. And again, we have our negative 17, negative 18, negative 19, negative 20, negative 16, negative 15, dot, dot, dot. We get 0, we get 1, we get 2, etc. So this case, we're still going to put our circle at negative 17, but now our answer includes, it's equal to negative 17 or lower. So we're going to color it in. And then we're going to draw our arrow saying all solutions less than negative 17 will work, including negative 17. Including negative 17. So we can summarize that by saying an open circle means do not include the number. Make this, move it up a little. A colored in circle means do include the number. Okay? Let's try some more examples. Okay, let's look at an example. Let's look at an example of multiplying or dividing inequalities. We did one just a minute ago using adding or subtracting with inequalities. Now we're going to do multiplying or dividing. So we're going to say y divided by 3 is greater than or equals to 5. Now, how do we solve this? If you remember, you always solve using, so the goal, let's put that, the goal is to get y by itself, and that marker doesn't work real well, using inverse operations. Goal is to get y by itself just as our last unit, using inverse operations. So we have a problem of division, y divided by 3. So what are we going to do to get y by itself? Well, we're going to use inverse or opposite operations. Since we are dividing by 3, we are going to multiply by 3 over 1. Whatever you do to one side, you need to do to the other side. So now let's see what happens when I do that. These 3's are going to cancel out and become 1's, right? And I'm going to be left with 1y over 1 is greater than or equal to, what do we got over here? We have 5 times 3 on the top and 1 on the bottoms. We could say this is the same as a 1 over there. So we end up with 15 on top and 1 on the bottom. So these 1's cross off. We're left with just y, or 1y. Remember, we dropped the 1 in front of the variable because any number multiplied by 1 is just the number. Y is greater than or equal to just 15. So that's our answer. And now we need to graph that. So you can go ahead at home if you'd like and see if you can graph that. So in this case, I'm going to start my 0 down here. That's, you can see that. -1, -2, etc. Right? Goes on forever. 1, 2, 3, 4, 5. I think I'm going to run out of room. 6, dot, dot, dot. We get to 15, 16, 17, 18. I'm just leaving off some numbers to save a little space. So reading this, Pac-Man eats the bigger number. Y is the bigger number. Y is greater than or equal to 15. So I'm going to start on the 15 here, right here. Now, am I going to put a closed circle or an open circle? Well, it does say it's greater than or equal to 15. So we're going to use a closed circle. Now, which way is our arrow going to go? Is it going to go to the left or is it going to go to the right? Yes, y is going to be greater than or equal to 15. Which numbers are greater than or equal to 15? The numbers going to the right. So our graph is going to look like that. Now we have to check, make sure that we did it right. Make sure our solution is correct. So we're going to check by picking a number that is within the shaded area of our graph. So we write the initial problem, y over 3 is greater than or equal to 5. That was our initial thing. And now we're going to pick a number along this part of the number line. So I'm just going to pick 18. So if I plug 18 in for y, I should get a true statement if I solved my inequality correctly. So 18 divided by 3 is greater than or equal to 5. Let's see if that's true. What's 18 divided by 3? Correct, it is 6. 6 is greater than or equal to 5. Is that a true statement? Is 6 greater than or equal to 5? That is true. So we know that we did the problem correctly. You can pause the video at any time to get this written down as needed or take notes, and then you can press play again. Okay. What about multiplying or dividing by a negative number? What's going to happen when we have that situation? Well, here's an example. We have negative 4x is greater than 52. Let's work on solving that one. So again, we want to get x by itself using inverse operations. So I'm going to divide. Inverse of multiplying is dividing. I'm going to divide by negative 4, but I'm also going to divide by negative 4 on that side. When I do that, my negatives cross off and I'm left with just 1x, or x is greater than, now what's 52 divided by negative 4? If you're not sure, top of your head, you can always do it long division. Negative 4 goes into 5 one time. 4 times 1 is 4. 5 minus 4 is 1. Bring down the 2. 4 goes into 12 3 times. 3 times 4 is 12. 12 minus 12 is 0. So 13 is my answer. So x is greater than 13. Okay, now here's where the issue comes in. Let's check our work and see what happens. So let's pick a number greater than 13 and plug it into our original equation. So our original equation was negative 4x. Actually, it's going to be negative 13 because we had a negative 4. Okay. So negative 4x is greater than 52. So we have to pick a number greater than negative 13. So think of a number closer to 0. So to the right of negative 13. So let's pick something easy. Let's pick negative 2. So let's plug in negative 2 because If I draw, like, let me just draw this. So here's negative 13. So we want something going to the right of negative 13, correct? So we're going to do negative 4 times negative 2 is greater than 52. Let's see what happens when we do that. Move that up. 2 times 4 is 8, right? Negative, two negatives make a positive. 8 is greater than 52. Is that a true statement? Is 8 greater than 52? Not true. Not true. So we came up with an issue, didn't we? This is why. Whenever you, and I'll write this down. Whenever you multiply or divide by a negative number, you have to flip or reverse. We'll use reverse. You have to reverse the inequality sign. Write this down. This is something that will definitely be something you're going to need to remember for many years to come. So whenever you multiply, I'll put the whole word there. Whenever you multiply or divide by a negative number, you have to reverse the inequality sign. So let's do that. Let's put, so we up here, when we did this initially, we divided by a negative 4 to both sides. So what we needed to do when we divided by a negative 4, we needed to flip the sign into that direction or reverse the sign the other way. So then our answer would be x is less than negative 13. So now if I try to check that, and I'll check that here. If I try to check that, negative 4x is greater than 52. And now I'm going to plug in a number that is less than negative 13, a number farther from 0. Let's try negative, I don't know, let's just try negative 14. So we have negative 4 times negative 14 is greater than 52. Let's see if that works out. So what is 14, negative 4 times negative 14? Well, if you don't know, you can always go up here and multiply. 4 times 4 is 16, carry the 1. 4 times 1 is 4, plus 1 is 5. So it is 16, carry the 1, 5, yeah. So it should be 56. Positive, right? Two negatives make a positive, is greater than 52. Is that a true statement? Is 56 greater than 52? Yes, that is a true statement. So I go back to my rule. Whenever you multiply or divide by a negative number, you have to reverse the inequality sign. Go ahead and write that down. Take notes, pause the video if needed. Okay, I'd like to look at page 208, guided practice problems. So if you need to get your book, we will be on page 208. Pause the video and then come right back. Okay, now that you've got your book open, this is the page we're going to be working from. Not going to be doing all of the problems. You'll be responsible to complete the ones we don't do on this video. So I'm going to go back under the document camera and I will write each problem number on the paper as we work. I think it'll be faster than trying to write on the screen. So we will do that. Okay, guided practice, page 208. Well, that's doing that. Number 2, negative 6 is less than negative 3. Divide both sides by negative 3. So I'm going to divide by -3 to this side. I'm going to divide by -3 to that side. Here is where we are dividing. Remember, if you multiply or divide by a negative number, you have to reverse the inequality sign. So -6 divided by -3 is going to give me a +2. -3 divided by -3 is going to give me a +1. Now I've got to reverse my sign. So it was going this way. It's going to need to go that way. So that is the answer for number 2. Next one I want to do is number 3. Number 3 is 7 is greater than -4. And they want us to subtract 7 from both sides. Okay, so if I subtract 7 from both sides, it's supposed to be a 7. I subtract 7 from both sides, I get 7 minus 7, 0, and I get -4 minus 7. So that's -4 minus 7, or -7 plus -7. I mean -4 plus -7, which then is -11. And my sign, it's subtracting or adding, right? In our case, we're subtracting, so we do not reverse the sign. So we keep it like that. So that is the answer to number 3. Okay, the next one I want to do is number 5. I think I might go back on the screen for that one. Okay, we're going to do this one on the screen. So I'm going to bring down my tools here. Move those over a little bit. So number 5, we have n minus 5 is greater than or equal to, how do I make an equal to? Well, we'll make one in just a minute. Greater than or equal to -8. No, greater than or equal to -2. And I'm going to draw a little greater than or equal to sign right here. So greater than or equal to it. So what do I do? My goal, I'm going to write that. Goal is to get the variable by itself using inverse operations. So to do that, I have a -5 here. So I am going to, you guessed it, add 5 to both sides. And my spacing should probably be single spacing. There, that's better. So now I end up with n by itself, because -5 and +5 is just 0. So I end up with n is greater than or equal to, let's draw my equal to, what? -2 plus +5, +3. And it should be a small n. Now, I didn't multiply or divide by any negative numbers, correct? So my sign stays the same. So my answer should be n is greater than or equal to 3. So how do I graph that? So I'm going to go over here, pick a color, And we have n being larger than or equal to 3. So first I need a shape. Now am I going to fill in the circle or am I going to leave the circle open at 3? Correct, it's or equal to. So I'm going to have a filled in circle. And what direction is my arrow going to go? My arrow is going to go, it's greater than 3 or equal to it. So my arrow has to go that direction. Correct? Correct. Okay. Gotta move my sign around here. Okay, let me put my answer in here as well. N is greater than or equal to 3. Draw my little line. There. So that's the answer. All right, number 7. Let's take a look at that one. Do that one over here as well. Number 7 is negative 7y. Here a little bit. Negative 7y is less than or equal to 14. Let's get our little less than or equal to sign in there. Right here. There we go. Okay, how do I solve this problem? We want to get, the goal is to get the variable by itself using inverse operations. So we have negative 7 times y. What's the inverse of multiplying? Correct, dividing. So we're going to divide both sides by negative 7 to both sides. Whatever you do to one side, you need to do to the other side. So we are going to do that. So negative 7 divided by negative 7 should give us a positive 1y, or just y. Now we're going to wait on the sign yet. 14 divided by negative 7 is, we have a positive 14, a negative 7, negative 2, correct. Now if you notice, we divided by a negative number. What is our rule? Our rule is if you multiply or divide by a negative number, you need to reverse the inequality sign. So, what direction is my inequality sign going to go? Correct. It is going to go this direction. And don't forget we have the or equals to underneath it. There. So y is greater than or equal to negative 2. And I will put that answer right here. Not that way. Y is greater than or equal to negative 2. Make my little line that goes underneath. Click over here, it should get rid of that blueness. Okay, now we have to graph it. So we have to, do we have to have a closed circle or an open circle? What do you think? Well, it does say or equal to, so we're going to start at negative 2. And yes, we are going to have a closed circle. I'll try to make this circle a little bigger than the last one that I did. And it should be at negative 2. I'm just going to move this. I'm going to move the move this a little bit. And I'm going to move this a little bit. Oh, I don't think I can do it. Yeah, it's not going to let me. So I'm going to move my little sign underneath here. There we go. Okay, so we have our circle at negative 2. Which way is our arrow going to go? y is greater than or equal to -2. So y has to be bigger than -2 to the right or to the left. Correct. We are going to go to the right of -2. There you go. It should be number 7. Now, if I wanted to check, I'm not going to check all of them right now, but you can do this at home. I am going to check number 7 and see if we did it right. So if I check it, I'm going to plug in a number that is greater than -2 and see if I get a true statement. So -7y originally was less than or equal to 14. Now if I'm plugging in for y, what's a number bigger than -2? We can just use something easy like 0, because 0 is greater than -2, isn't it? So we'll do that. So let's see if that's true. Is -7 times 0 greater than or less than 14? Or less than or equal to? So 0 is less than 14. Is that true? Yes, that is a true statement. So we did the inequality correctly. We solved it correctly. Okay, the last one I would like to do is number 9. I'm going to erase some of this stuff. Let's get rid of all this. Okay. Now, number 9, I'm going to move this up. So I'm probably going to have to clear my drawings. Hopefully you got that down before I erased it. If not, go back and review the video or rewind it. Okay, number 9. For a scientific experiment, a physicist must make sure that the temperature of a metal at 0 degrees Celsius gets no colder than -80 degrees Celsius. The physicist changes the metal's temperature at a steady rate of -4 degrees Celsius per hour. So this is a rate. We always know that a rate means multiplying by a variable. And we know it's going to get no colder than. That's another hint that it's going to be an inequality. For how long can the physicist change the temperature? So letter A, my spotlight out here. Let T represent temperature in degrees Celsius. Write an inequality. Use the fact that the rate of change in temperature times the number of hours equals the final temperature. So if I go over here, T is going to equal temperature, correct? So now if I'm going to make an inequality, we know that the temperature goes down by 4 degrees, right? Every time. And it can be no colder than -80. So does that mean it's going to be greater than, right? It has to be greater than -80 degrees Celsius. However, can it be equal to -80 degrees Celsius? Exactly, it can, because it says it can be no colder than. So -80 is included, so we have to put the little line under the equals. So that would be number A, or letter A. -4t is greater than or equal to -80. A little line under there. And I wanted that to be red. So let's erase that and make it red. Okay. Now the next question says, solve the inequality in part A. How long can the physicist change the temperature of the metal? Let's see. We are going to solve by inverse operations. So we have a -4. So we are going to divide by a -4 to both sides of the inequality. -4, because the inverse of multiplying is dividing. We now are given t because the -4 divided by the -4 cancels out to 1, or just t. T is now greater than, oh, wait a minute. Is it greater than? we divided by a negative number. So t, we're going to have to flip the sign, is going to be less than or equal to, little equal sign there, less than or equal to what? What's negative 80 divided by negative 4? Positive 20. Right? So how long can the physicist change the temperature of the metal? The answer is 20 or fewer hours. So T really isn't representing time, even though it's, what is it telling us that? So T is not representing temperature. Oops. T is representing time. I'm going to go back and fix that. T-I-M-E, not temperature, time. So the time he can reduce the temperature is 20 or fewer hours. Letter C, the physicist has to repeat the experiment if the metal gets cooler than negative 80 degrees Celsius. How many hours would the physicist have to cool the metal for this to happen? Well, he would have to cool it for more than 20 hours. So basically the same thing, just stated differently. Okay. So we can get to our homework. Our homework is going to be to complete page 208, the problems we didn't do on the video, and also independent practice, page 209 to 210, numbers 11 through 25. All right. If you have any questions, I'm going to clear all my drawings. If you have any questions in the meantime, feel free to email me. My hours of appointments are available for individual help on Zoom. If you would like to do that, feel free to contact me by email, by text, call me on the phone, Instagram, anything like that would be fine. Just want to make sure that I'm connecting with you guys. So I hope you have a great day, and we will see you soon. Bye.